Let's look at 2.1 complex numbers. So we are going into when we have imaginary numbers. So imaginary numbers is whenever you have a quadratic equation that has no real solutions. So remember that a solution for quadratic is where it crosses the x-intercept. So I'm going to put solution is our x-intercept. So when it has no real solutions, that means it doesn't cross the x-axis at all. But we can't just say no real solutions. We actually find those solutions and they're imaginary solutions. So the way that you might see this is if we have this equation, then I would do like x squared plus 1 equals 0. If I want to just solve for x and find the actual solution, I'd do minus 1, and I get x squared equals negative 1. And then to solve it, you take the square root, and so we get x equals plus minus square root of negative 1. So that is not going to work, and the reason that's not going to work is because you can't square root a negative. There's nothing that it will equal. So this is where we get into imaginary numbers, okay? So this is important to remember. I is when you have the square root of negative 1, and I squared equals negative 1. So we're going to refer back to that quite a bit. Okay, each complex number can be written in standard form. So this is our standard form. This is our real part, and this is our imaginary part, or complex part. Imaginary. Okay, so each complex number can be written in standard form. So we would want to put the real part first. So I'm going to do negative 5. And then I'm going to break this down. Well, I know that the square root, I can pull out a negative 1 from negative 9, and then I can do 9. So I'm breaking it up into two parts. So this is 3, and this is I. But I need to write it the opposite way. So this is actually 3I. So I can put that on after the negative 5 because I want it in standard form. This is my real part. This is my imaginary part, making us a complex number. So let's look at a definition of complex number. If a and b are real numbers, then the number a plus bi is a complex number is said to be written in standard form. If b equals 0, then the number a plus bi is a real number because it'd be 0i. If b is not 0, then we'll have a plus bi, and that is our imaginary number. A number in the form of bi, where b doesn't equal 0, is called purely imaginary. So we are going to do operations with complex numbers. We're going to combine, we're going to simplify them, just like we would simplify an expression with x's and x squareds and all of that. So an additive inverse zeroes out the complex number. So a plus bi, the additive inverse would be the complete opposite of that. Negative a minus bi. That is your additive inverse. Start with this. All right. We need to simplify. So I'm just going to take out the parentheses. 3 plus 2i. Next one would be plus 4 minus I. And then we got to change the sign of everything here. So negative 7 plus I. Then we would combine like terms. So what I meant by that is you do your real part, and then you do your imaginary part separate. So 3 plus 4 is 7, minus 7 is 0. So those actually will cancel out because they equal 0. Now I'm going to combine the i's. So I have 2i minus I, that'd be 1i, plus 1i is 2i. let's go to the next one. Going to do the same thing, get rid of parentheses. So this is 3. That's going to be plus 2 minus 3i. And then this is all positive, so really that's going to be minus 5 plus I. Then combine your like terms. So our constant 3 plus 2 is 5, minus 5 is 0. So it's not always going to do that. It just did it on these examples, so don't get used to that. All right, negative 3i plus 2i is negative 2i. I don't know if I said that right. Negative 3i plus I is negative 2i. Okay, let's look at this one. All right, we don't have any i's here, but we have square roots that need to be broken down. So before I even begin, I am going to break these guys down and see if I can get onto the imaginary parts. So I'm going to come over here. I'm going to do square root of negative 27. And this is like simplifying a radical. You want to find the perfect square that is a multiple or a divisor of 27. I'm going to go ahead and take out negative 1. And I know 9 times 3 is 27, so it's going to be 9 times 9 times 3. So I can bring out this, and that's I. I can bring out this, that's 3. And then this is just brought down. So I now have 5 plus 3i squared of 3. Okay, now I need to do square root of negative 48. So I'm going to start with negative 1. Then let's think through some numbers. So 4 will go into this, but also 16. So I'm going to do 16 times 3. So this is I. Square root of 16 is 4. And then just bring down square root of 3. So this is going to be minus, parentheses, 4i square root of 3. All right, we need to get rid of parentheses. So we have 5 plus 3i square root of 3. And then, oh, I forgot the 12. Whoops, let me fix that. Let me fix this real quick. Hang on. So this would be minus negative 12 plus 4i squared 3. There we go. So then we distribute that. So it'd be plus 12 minus 4i squared of 3. All right, we're going to combine like terms again. So I'm going to do my real part first. So 5 plus 12 is 17. Okay, and then the way that you can combine these if they are like terms. So what I mean by like terms here, they have to have the exact same radical. Same imaginary part or same radical. So that means I can do 3i minus 4i is a negative 1i, and then keep your same square root of 3. All right, let's do some more. Let's go to the next page. So more operations. All right, we need to see if we can break these down. So I'm going to break this down. That would be, I could take out the negative 1, which is I, and square root of 3 can't be reduced. I square root of 3. Okay, this one though, it does have a perfect square. So it'd be I square root of 9 times square root of 2. Oh, 2, not that. So that would be times 3i square root of 2. Okay, whenever you multiply, we're going to multiply the imaginary part first and then the radical. So I'm going to do I times 3i is 3i squared. And then The square root of 3 times square root of 2 is really square root of 6. We can combine those. So what I could have done is I times 3i square root of 3 square root of 2. And this was the 3i squared, and this was square root of 6. Okay, remember how we wrote at the very beginning? This important thing right here? I squared is negative 1. So I'm going to change this I squared that we have here into times negative 1. So 3 times negative 1 square root of 6, which would be negative 3 square root of 6. So we don't have an imaginary part anymore. We were able to simplify it out. Okay, let's go to the next one. All right, this is multiplying. So some of you might like FOIL, some of you might like the box method. It's really up to you. I'm going to, for space, I'm going to go ahead and do FOIL 8 plus 6i minus 4i minus 3i squared. Remember, I want my real part first, and then I'm going to combine my middle term. So 8 plus 10i, and then minus 3. Remember, I squared is negative 1. So this becomes positive 3. So it's 8 plus 10i plus 3. Then I can combine these. And I get 11 plus 10i. Oh, you know what I messed up on? This should have been 2i. Because I can't add those. That's a 2i. Okay, there we go. All right, let's go to the next one. Square root of negative 10 squared. So remember, square roots and squareds basically cancel each other out. So this would just equal negative 10. If we were to break it down, let's do it. So this is the inverse way. The other way would be square root of negative 1, square root of 10, which just would be I. And this is all squared, right? I times I square root of 10 squared, which is I squared times 10. I squared is negative 1, so negative 1 times 10, which equals negative 10. Okay, so that's two different ways of looking at it. They both work. Okay, let's go to number 7. Okay, we need to distribute. So that would be 32i plus 20i squared. So this I squared is negative 1, so 20 times negative 1 is negative 20 plus 32i. Because you always want the real part first. Now let's go to the next one. All right, this is going to take a little bit of work, and we're going to need quite a bit of room here, okay? So I'm going to start out with this guy here. So that would be 4 plus 5i times 4 plus 5i. So we can do FOIL or the box. So 16 plus 20i plus 20i plus 25i squared. Let's go ahead and simplify this whole down. So that'd be 16 plus 40i. That would be, because of that, would be minus 25. So 16 minus 25. I'm going to bring it over here. So that would be negative 9 plus 40i. Okay, so we just did that part. So now we got to do this other part right here. So it's going to be minus. Okay, so minus parenthesis 4 minus 5i times 4 minus 5i. Similar, all right? So minus, that would be 16 minus 20i minus 20i plus 25i squared. This becomes negative 25. 16 minus 25 is negative 9, and then minus 40i. All right, so this goes over here, but I'm going to go ahead and change it. So, well, I'm going to do this. I'm going to get a different color. Nope, same color. Okay, so that's going to be negative 9 plus 40i plus 9 plus 40i. And that's because I did this negative here. So we're going to combine like terms. So negative 9 plus 9 is 0. But then we have 40i plus 40i is 80i. Okay. So that took a little bit of work, but we were able to finish it out. Okay, let's talk about complex conjugates. So they are the same binomial, just a different sign. So we have here a plus bi and a minus bi. Those are complex conjugates. And the reason we want to do this is so we can knock out the imaginary part to get rid of I. So I'll show you how that works. So let's go ahead and do this. So it's I, and then minus I, plus I, minus I squared. The middle terms cancel. I get 1. And then remember this is negative 1. So if I have minus a negative 1, that's going to be plus 1, which gives us 2. So see how we have no imaginary number anymore? Because we got rid of it by multiplying by its conjugate. Okay, so let's look at this one. So that'd be 16 minus 12i, and this plus 12i, and this minus 9i squared. Okay, these guys are going to cancel. I get 16, and then this is times negative 1. So it's minus 9 times negative 1. So it's going to be 16 plus 9, which is 25. Okay, so whenever you multiply it by the conjugate, that gets rid of your imaginary part. Okay, so the reason we want to do this is because of when you're dealing with fractions, just like you can't leave a fraction with a radical in the denominator, you can't leave imaginary on the denominator. So we are going to multiply by a funny looking 1. So what I mean by that is when you multiply top and bottom by the exact same thing, that's like multiplying by 1. So what I'm going to do is multiply by its conjugate, denominator's conjugate. Whatever you do on bottom, you have to do on top. All right, so let's go ahead and do the top and do a different color. So it's going to be 8 plus 8 plus 4i plus 12i plus 6i squared. Okay, and then the denominator, let's do this, 16 plus 8i minus 8i minus 4i squared. So the denominator we need to go ahead and get rid of that, right? So let me simplify this. So 8 plus 16i. And then this is going to be -1, so -6. I'm going to reduce the top real quick. All right, and then 8 minus 6 is 2. So 2 plus 16i. And then we can do the next one. 16 minus 4i squared. So this is going to turn into -1. So it's 16 plus 4. So it's 20. All right, we're not done here. When I look at this, I see everything is even. So I'm going to factor out an even here. So 2, 1 plus 8i over 20. Then I can simplify these numbers. So it's going to be 1 plus 8i over 10. Because the 2 cancels to 1, or simplifies to 1, this cancels to 10. So 1 plus 8i over 10. Okay, let's go to the next one. Multiply by its conjugate because we can't have imaginary on the denominator. So I'm going to do 4 plus 5i. 4 plus 5i. So remember, this is just multiplying by 1 when you multiply top and bottom by the same number. All right, so let's do the top. So that's 8 plus 10i. Okay, then the denominator, we have 16 minus 20i minus 20i, and then multiply -5 times +5i. So that'd be minus 25i squared. All right, so I have 8 plus 10i. These guys cancel each other. Then I get 16 minus 25 times a -1, so that'd be plus 25. So 8 plus 10i. 16 plus 25 is 41. And we can't reduce anything. See how they're not all evens or not all multiples of the same number. So that is how we know that we are done. We cannot simplify anymore. Okay, let's see. We have 2 more. So let's look here. All right, we're simplifying, putting it in standard form. So this is going to be -6. And then I cubed means I 3 times, right? But I can take out a squared and keep another I. And the reason I did that is because I squared times I1 is I cubed. And what we want is to be able to take this I cubed and make it -1. So plus, that is going to be -1. This is going to be -1. So -6 times -1 times I minus 1. And so that ends up being +6i minus 1. But to put it in standard form, we're going to do this one first. So -1 plus 6i. Okay, one last problem to do. All right, so this one's a booger right here. All right, what we're going to do is we're going to break this down into -75 times -75 times -75. So that means I have -1 times, let's break this down into perfect squares. That would be a 25 times 3. So that would be square root of 25 times 3. Square root of 3. So that's just one of these, okay? We're going to do that 3 more times. -1, square root of 25, square root of 3. -1, square root of 25, square root of 3. All right. Anytime you have 2, you can pull them out. But what I'm actually going to do is I'm going to go ahead and pull these guys out. So that's I 1, 2, 3, 3 i's, right? I cubed. And then we have 5, 5, 5. So times 5, times 5, times 5. And we have square root of 3, square root of 3, square root of 3. Okay, so with this, I do have an I squared in there. So remember, I have an I squared, an I, and then 5 times 5 times 5 is 125. And then I could change this to square root of 9. And the reason I did that is because 9 is a perfect square. So I'm going to do lots of different things here. I'm going to change this to a -1. -1, or -1 times I, and then times 125 times 3, square root of 3. Okay, so now I'm going to simplify. So we have a negative. We're going to go ahead and do this. 125 times 3 is 375. And then carry down your I, and then square root of 3. So it's kind of messy, but we were able to finish it out. All right, the rest, I do want you to go ahead and try those in-class problems so that whenever you come to class, we can look over and see how you did, where you got stuck, what you did well on.